Yep, go ahead.
I guess maybe when I go to Davis, it's
I have a video, but will the video feed be faster because it's not recording what's the overhead projector is like showing? It's giving it directly from the computer? Or because you said there was a latency issue with when you move your hand and stuff like that.
Right.
Would it be faster on the video because it's
I don't think so. I don't think that affects it because I do the same thing at home. When I'm just playing with it without any type of recording, and it's still slow. It has to do with the document camera has to send basically 2 megabytes or so of stuff through USB 2.0, and there's an internal hub to this device because it's not a single device. It has a camera on top, has a microphone. It also has a little mass door device that includes its own drivers. So you can plug it into a computer that has no driver, no application installed, and the files are already there. So that's why there's an internal hub to this thing, and there's probably another hub inside the box. So you have to go through 2 hubs at least using USB 2.0, and I'm not even sure whether it even connects at 480 megabits per second or 12 megabits per second. So I think it's really just the bandwidth of USB limiting how fast you can refresh. I tried out a different brand of document camera, same thing, same kind of latency. The only way to make it a little bit better is to reduce the resolution. Then you don't have to send as many pixels over, and as a result, it goes a little bit faster. Okay, so looking at the exam schedule, this class starts on between 10:30. So this is a 10:30 class on Tuesday, Thursday. So this is our exam date, and time is 10:15 to 12:15. So we will have our exam next Thursday from 10:15 to 12:15.
Is it in here or is it going to be
I'm thinking about here, but I think going to the lab is not out of my consideration. So it depends on whether the class wants to would object to taking this class online or not. Because by default this class is a face-to-face class, and so we'll do everything on paper. But if there's no objection, I can also consider doing this through Moodle as an online test, online quiz. Is there any objection to that?
No.
I think if we're going to be tracing stuff, it's easier.
Well, then you do the pre and
Maybe.
post condition, though.
Sorry?
Then you do the pre and post, you can write all that out.
You have to write it out using a text editor, just like I usually do. But you can type probably faster than you can write. And it will be open book, open notes too. So if it is online, then you can actually have everything available online, and you can do the Google search too. But there's no test bank for this class, so there's really nothing to find except for my own notes.
Except for movies.
But there's one distinct advantage of taking this class online, when it's open book, open notes, and open YouTube, because people can actually watch YouTube again during the exam to kind of refresh their memory about certain things. And I'm not kidding. Some people actually did that, and it's okay. I mean, if you know exactly where to go, spending a few seconds, in YouTube, just to look up. Oh, so this is how it's done. It's not a bad thing. I mean, if you have the index of everything already, it's okay.
The only problem is it takes a while to get to the videos to the point where you can actually watch what you want to see.
I think there's a way to bookmark, the exact time of certain
They have it
things.
set now where you can start them at a certain point. They have
Yeah.
a feature on it. You can make it start at a certain
Right.
Copy URL at certain times and directly come to you.
Oh, you can do certain things with
Yeah.
the URL to position it too. Yeah, so you can actually position it, and you can save your own bookmarks on your thumb drive. So at the lab, you plug it in, and you go, okay, I need to remember exactly how to invoke a subroutine that has a return value. What do I need to do to set it up? You can just click on one link, from your thumb drive, brings you to the YouTube clip, exactly where you need to watch. But you have to do all the indexing first, which means you are going to do the studying anyway. So it's really nothing more than an aid to help you through the exam. But by the time you have all those bookmarks, I will think that most of that knowledge is already up here, and you actually do not really need to look it up anymore.
One would hope.
One would hope. Okay, so our exam time is 1 hour, it would be 2 hours. And I will decide whether to go to the lab or not. I have to talk to the lab manager to make sure that there is enough room in the lab. I think at this point there will be enough room for this class. Initially for this class, because it's too big, we would not be able to fit the class into the lab. I think now we can.
But people quit.
Well, people quit for different reasons. Maybe some people get a new job. Their schedule changed. So there are reasons why people are not available anymore. Are there any questions about the binary search homework assignment? Okay, has anyone gotten started on it? I know some people have, because I've been getting questions from a few people. That's a good sign, okay? Because this is certainly one of those things you want to start a little bit early, just so that you can get a hang of it, or if you have questions, you can ask questions. So are there any questions about this particular homework assignment? It really only makes use of concepts that we have talked about in this class, but it is complicated in a way because you have to track a lot of things, along the way. No questions? If there are no questions, if no one is objecting, do you guys want me to kind of go over and review pre and post condition first? Because that's the one topic that we have not touched for a long time, and it might be something that we want to kind of revisit before the exam. Okay, so this will give us a little bit more time to revisit all that stuff. So let me close the other tabs first. Yeah, we were talking about virtualization in my other class, phishing, stuff like that. All right. So let's go back to pre and post conditions, and that is in topic 4. All right. Now, before we talk about the actual specifics, I think it is more important to understand the general concepts first. The mechanisms are also important, but I think understanding why we have to understand this stuff is also important. Okay. So what I'll do is I'm going to start with maybe a fairly simple example first, and then we'll go from there. I'm going to use mouse pad for this purpose, which has line numbers enabled, which is kind of helpful because I can now point to a particular line. You guys can ask questions based on line numbers too. Okay. So I will go ahead and have line numbers for the algorithm itself too. So let's say line 1 is x gets a value of 0. Line 2 says x gets x plus 3, and then line 3 says x gets x times 2. Okay. Let's make this more fun and turn this into k. Okay. And I will give you a known, a beginning. So every time we work with a pre and post condition thing, I have to give you something. I have to either give you the pre-condition of everything, and you have to derive the post condition of the last one. Or I can give you the post condition of everything, and then you have to work your way back up, and then you have to say, okay, the precondition of this entire chunk of code has to be blah, blah, blah. Okay? So in this case, I'm telling you, this is given to you, that the precondition of line 1 is true. What is that really saying? It's saying that we don't know anything. Okay? Because the expression true is the simplest expression that is true without having to say anything about the variables. Now, if I say ahead of time and say, okay, pre1 is y equals to 20, that's telling you something. Okay, it's telling you that variable y, which I'm not even using here, has a value of 20 to begin with. If I just say that the precondition of line 1 is true, I'm saying I don't know anything about any variable at this point. It doesn't mean that they do not have any values. It's just that as a precondition, I do not know anything. Yep.
If you say that the precondition of line 1 is true, then that means the variables exist.
Yeah, in this class, we can assume that global variables always exist. But the values, we may or may not know anything about the values. And that's what the precondition is for. All right. So now that we know line 1 has a precondition of true, we want to derive the post condition of line 1. In other words, I'm asking, if I tell you that before line 1 executes, we know nothing, okay? What can we say after line 1 executes? That's really what the question is asking. Now in this class, we have a fairly mechanical way to go from the precondition to the post condition for assignment statements and also for conditional statements. For loops, it's kind of complicated, and I can basically tell you that there will be no loops in pre and post condition questions in the exam. So we can kind of not worry about loops, but we still have to kind of think about pre and post conditions for conditional statements. But we'll deal with that later. Okay, this one is not a conditional statement, it's really just an assignment statement. All right. So there are questions that you can ask to help guide you to apply the right mechanism to derive the post condition. The condition or the question we are asking is, does the right-hand side refer to the left-hand side on line 1? That is a very good indicator, or at least the first question to ask, because if the answer of this is the right-hand side does not refer to the left-hand side, you really don't have a choice, because there's no way to undo the operation. Then you have to use the forget operation. Okay? So in this case, on line 1, does the right-hand side expression refer to the left-hand side, which is the variable that we are changing?
No.
No, because k is not x, so obviously it does not. Okay? So the answer is no. This means we have to apply the forget. You can call it the forget rule, or you can call it the forget mechanism. Either way is fine. Okay, in a forget rule or in a forget mechanism, the post condition is dependent on the precondition. But it's not really just that. It is after you forget certain things in the precondition. Now, because the operation is not reversible, that means the very same variable that we are changing in on line 1 in this case, everything that we knew about it, we have to forget it, because that stuff may not hold true anymore in general. But at the same time, after the assignment statement, you can also know for sure that x equals to k at that point. So the post condition of line 1 involves getting rid of some stuff that we knew about x in the precondition of line 1. But on top of that, we can also add one more fact, that x has to equal to k at this point. Is that making any sense? So look beyond the mechanism, the mechanism, and focus on the concept. Does that make sense? Okay. This is in general. Okay. In certain specific cases, we don't really have to forget as much as we usually do, but in general, this will always work. Now, it is very important that we use an equal sign here and not the assignment symbol, because those two represent completely different things in this class. This symbol here, the left arrow symbol, is a symbol of assignment operation. In other words, we are updating the left-hand side with the right-hand side. It is not a Boolean expression. It does not tell you something that is true or false. It is just doing something to the variable x in this case. So this is the wrong context to use the left arrow. In this context, where we're expecting something to be either true or false, we have to use the equality symbol to basically say, we're asking the question, is it true or is it false that x equals to k? But the precondition has to be true in order for a statement to be reachable. Okay, we talked about how a precondition of false indicates a dead branch. So in this case, as long as this condition is true, we can actually, this is not a dead branch. All right. So the next line, I just expand what is pre1. That's easy. Pre1 is given to me. It is simply true. And true does not refer to x at all. Okay, so there is nothing to forget. So the end result becomes true and x equals to k. And we can do one more simplification here. T is called the identity of conjunction, which means T and whatever is whatever. And that's why we can get rid of T and just be left with x equals to k. Is everybody starting to recall the pre and post conditions? Okay. So knowing post 1, we can try to link it to pre 2. Pre 2 equals to post 1 because lines 1 and 2 are sequential. Now there are times where statements seem to be next to each other, but they are not really sequential. In other words, after one line, you don't necessarily get to the next line. But in this case, they are sequential. Okay, after you perform line 1, you always go to line 2 in this case. And that's why we can say the post condition of line 1 is the precondition of line 2 because line 2 follows line 1. Yep.
Subroutines won't be in this then.
I will not have pre and post condition questions in the context of subroutines. Correct. Because in that case, it would be fun because recursion has no loops and it can have conditional statements. So that would be interesting is to prove the correctness of a recursive algorithm because it doesn't have a loop. Okay, so I can say, well, I said I would not have any questions about loops and I can, basically fulfill that requirement. But to prove the correctness of a recursive algorithm requires an understanding of proof by induction, and usually also proof by contradiction of one of the more advanced techniques of proving, and that's way beyond the scope of this class. It's not mechanical at all like this stuff here is. Okay, so moving on to line 2. Okay, we want to derive post 2 from something applied to pre 2. Because that's the whole purpose. How do we go from the precondition of a particular line to the post condition? So the question now is, what do we do so that we can relate the post condition of line 2 to the precondition of the same line? Well, we'll go ahead and ask the same question. Does the right-hand side refer to the left-hand side on line 2? The answer is yes in this case, because x plus 3 refers to x. In other words, the very same variable that we're changing on line 2 appears on the right-hand side. It is used to specify, to calculate its own new value. Are we doing okay so far? Okay. Now that is really helpful because it gives me a chance to reverse the operation. If I can reverse the operation, then I can make the whatever statement that was true with x before line 2 executes, I can still make them true. I just have to play some tricks with x itself to reverse it so that I'm representing the same value as it was before the operation. Okay. Well, even after you answer the question whether the right-hand side refers to the left-hand side, you still have to answer a second question. Okay. If f of x, the right-hand side, is x plus 3. Is there an inverse function? That is the second question. In other words, if the left-hand side refers to the right-hand side, to the other way around, if the right-hand side refers to the left-hand side, you still have to answer the question, is it reversible? Because there are expressions that are not reversible, and yet they refer to a particular variable. I can give you one example, x minus x. Okay, if I say x gets x minus x, it's getting the value 0. But knowing that in the post operation, it is a 0, I can never go back to the original value of x. So in that case, the answer to this question, does the right-hand side refer to the left-hand side? It is true, it's a yes. But the operation itself or the function itself is not reversible. There's no inverse function. So you've got to be sure that there is an inverse function before you go any further. So in this case, the answer is yes to that question as well. And then we can say f of x is x plus 3, the inverse function, which in this class I use f prime to represent it is x minus 3. In other words, to reverse the operation of adding something to x, you just have to subtract 3 from x. Yep.
So what happens if the right-hand side does refer to the left-hand side, but there is no inverse? Or
Then you still have to use the forget rule.
Okay.
Because in that case, the right-hand side effectively evaluates to a constant. Like x minus x is 0. X times 0 is also 0. So in all of those cases, you have any value of x transferring or transforming into 0 itself. Right? So now that we have an inverse function, then we can say use the substitution operation, or if you want to use, say rule. The substitution operation goes like this. We are starting with pre2, and then we say every time you see the variable on the left-hand side, which is x in this case, replace it with f prime applied to x. This is the template of applying the substitution rule. After the first line, you can expand what is pre2. Pre2 is post1, which is really just saying x equals to k. I still want to replace every occurrence of x with something. F prime of x, we already know is x minus 3. I put an extra pair of parentheses around x minus 3, just so that I don't have to deal with the precedence of operators and stuff like that. Just in case there's multiplication involved, this won't cause any problems. And then on the third line, we actually apply the operation, which is looking at x minus k, and then we say, oh, there's one occurrence of x right here, replace it with x minus 3, and we're done. There's no need to simplify because putting a plus 3 on the other side is not any simpler than the way it is right now, so I can just leave it the way it is. And besides, this is not an algebra class, so you're not really required to do the simplification if there's no need to, especially in this case. Any questions about post 2, or the way we find out what post 2 is? Yep.
Can you go over that inverse stuff again?
The inverse stuff?
Yeah, on line 19. Can you give me an example of when it won't have an inverse?
Okay. So we're going to use the other part here. F of x equals x minus x. There's no inverse.
Okay.
Yep. Because f of x, in that case, x, if it has to do with x minus x is a constant. Regardless of the actual value of x, x minus x always gives you 0. And that's why, knowing that after the operation x has a value of 0, there's no way to go back in time and say, oh, you know what? I know what x was before this statement because it can go in any direction. Okay. All right. So getting back to here, now we have to deal with line 3. Line 3 is this, and it's immediately after line 2. Those two lines are sequential. So what you can do now is to say pre3 equals to post 2 equals x minus 3 equals k. Because lines 2 and 3 are sequential. And now we have to ask basically the same questions again. I'm going to copy and paste a little bit and then change certain parts of it. The first question is, does the right-hand side refer to the left-hand side on line 2? In this case, it is line 3. The answer is yes. If the right-hand side is x times 2, is there an inverse function? And the answer is yes as well. The only way to reverse multiplying something by 2 is to divide it by 2, or times 0.5 if you will. Same thing. Is that making any sense so far? That means we can also use the substitution rule. Post 3 depends on post 3 depends on pre3, but only after a substitution operation. So we look at whatever is in pre3, we look at all the occurrences of x, replace each one with f prime, the inverse function applied to x. And then the second line, we just expand everything here. Pre3 is x minus 3 equals k. Like that. And then f prime of x is x divided by 2. So after the substitution operation, you end up with x divided by 2 minus 3 equals k. Are there any questions about this? And that's the post condition of the entire sequence of statements. How do I check this? I mean, I didn't even tell you what k is. So can we even check it? I mean, you can just go backwards. You can always go backwards, or you can put, you can You can trace this with a particular value of k. I mean, you can definitely do it that way too. Okay, so let's go ahead and double check and make sure that this actually makes sense. All right, so if you do it the trace way, but now remember, tracing only works in certain cases. Okay, I'm just using it to kind of give you an additional tool that works sometimes. So in this case, okay, let me keep this line down a little bit. So I'm just starting a new column here. Let's assume k is 5. Okay. Now if k is 5, then x equals 5 at the end of the first line, right? Because k is 5. After the second line, x gets x plus 3, so x would have a value of 8. After the third line, x should have a value of 16. Is that making any sense? Okay, so now what we want to do is to look at the post condition specified here. And then we want to say, is this statement, not the entire thing, is this statement going to be true at the end of line 3? Okay, so I'm just going to paste it here. Is that true? Well, let's take a look here. So we are basically asking 16 minus 2 minus 16 divided by 2 and then minus 3. Does that equal to 5? Yep, it works out. 16 divided by 2 is 8. 8 minus 3 is 5. So it's a really quick check, to see that, okay, it makes sense. At least in the case that k equals 5. Now, in this case, you can basically say, yeah, but it will be true regardless of the value of k. K can be 0, and this will be true. K can be 200, this will be true. K can be -5, and this will be true. Okay? Well, that's because this is a simple example. But there are cases, especially when conditional statements are involved, you can no longer just plug a value in to see whether it works or not, because now you have branches. So sometimes it goes in this way, sometimes it goes in the other way. All right, so are there any questions about this particular example before we move on? Yep, go ahead.
Let's go down to the bottom and then like get the last part of it.
Okay. Yep.
But in a condition, or if you had a program with conditional statements and you were doing pre and post conditions for it, when you got to the last line of the program, you'd have this or that.
Mm-hmm. Yep, because after the merging of the paths, you no longer know which way you came from.
What about loop invariance?
That won't be in the exam. The only thing you do have to know, just in general, okay, not for this class, not for the exam, is if you have a while loop, and let's say the condition of the while loop is C, okay? C can be a really long or short, expression. The only thing you really have to know is when you get out of the loop, C has to be false. Okay? Now that seems to be pretty, easy and straightforward, but it is one of the most important part that you have to remember, because this is how you can analyze your code, is to say, okay, I'm out of this loop here, and something is not right. So you can start with the condition of the loop, and you can say, that has to be false, because I'm out of the loop now. Okay? And it does not require any loop invariance in this case. It does not require any pre and post conditions, but it does tell you something that is important, because it tells you that that condition has to be false, because you're now outside of the loop.
A necessary condition. A necessary condition to exit.
To get out of the loop, right. All right, so let's go ahead and have another example, but this time using conditional statements. And we'll start with something that we are very, very familiar with. Okay, well, we should be. Okay, and I'll give them line numbers. That's line 1, line 2, 3. Are the line numbers coming from the editor interfering? Do you want me to turn it down? No.
No.
That's okay? All right.
They're all grayed out.
Okay, So this is our conditional statement, and I want to go forward. In other words, I give you the precondition, and we'll derive the postcondition. So in this case, we'll go ahead and say the precondition of line 1 is once again true. Now this time it looks kind of really weird because it looks like with the previous one, with k being unknown, we can still go forward, because we can still do all the calculations using algebra to figure out what x will be, even though we don't know what k is. But in this case, it doesn't seem to make sense, because if we don't know anything about x or y, how do we know which way we are going in this conditional statement? But that really is the whole point of a pre and post condition type of derivation instead of tracing. It is just analyzing the structure based on the structure of the code and not based on the actual values of the variables. In other words, it's trying to make a conclusion on line 5 and say, regardless of the values of x and y, this condition, post 5, has to be true. And that's the whole essence of pre and post conditions. All right. So in this case, there are certain things that really doesn't work anymore from the previous example. For instance, I cannot say that line 2 is sequential to line 1 anymore, because it is not always the case that after line 1 that I want to execute line 2. Sometimes I want to execute line 2, other times I want to execute line 4. So that's why it is no longer sequential, and the way you document it will be different too. Okay? So in this case, we can only say something about pre-2. In other words, if I am about to execute line 2, what do I know for sure at that time? Technically speaking, you have to start with pre-1, and then the condition of the conditional statement. There's only one exception to this rule, but since we're not throwing subroutines into this whole mix, this will still have to be true. The only time when you cannot guarantee pre-1 anymore as a part of pre-2 is when you are invoking a subroutine to determine the condition of a conditional statement. Because the calling or the invoking of that subroutine can have side effects that can change the values of your variables. And as a result, pre-1 may not be true anymore because the subroutine you're invoking inside the condition can change variables as a result, as a side effect. But since we're not dealing with subroutines in this case, we have to say that whatever was true in pre-1 still has to be true at this point. Is that making any sense? Okay. So in general, you have to say it like this. The precondition is still true because we haven't had a chance to actually change anything. Now, in this particular case, because pre-1 turns out to be just true, we can simplify the whole thing to really just x is greater than y, which seems like we did not have to include pre-1 in the derivation. But that's only because in this case the pre-1 is so special that we can simplify it out in the end. Is that okay? All right. And I personally like to work with pre-4 next. You can work with post 2 if you want to. The ordering in this case is not important. You can move forward to the post condition of line 2 or just the precondition of line 4. I look at line 4 first because structurally speaking, I want to handle the entire structure of the conditional statement first, and then I can focus on what is inside the conditional statement, and I can just focus on the assignment statements after that. But that's a personal preference. With pre-4, we still have to say whatever was true in pre-1 still has to be true, because if I'm just about to execute line 4, I did not have a chance to modify any variables just yet. So whatever is in pre-1 still has to be true, but then the condition of the conditional statement has to be false, because otherwise I would not be on line 4, or I would not be about to execute line 4. Are there any questions about the derivation on line 53 of the document? Yeah, go ahead.
You could also say x is less than or equal to y, correct?
That is correct. Yeah, but I want to emphasize is the negation of the condition of line 1. So the next line I can do the change, so I don't use negation on the outside and just use the comparison to compensate for it. So now we can just say that pre1 is true and not x is greater than y is x is less than or equal to y. And then we can simplify true and anything out of it because true and whatever is just whatever. In this case, it is x is less than or equal to y. Are there any questions about the preconditions of line 2 and line 4? No questions? All right. Now we can try to derive post 2. Well, in order to derive post 2 from pre2, the fact that we are inside a conditional statement does not matter at all. Okay, because line 2, if you just focus on line 2 by itself, it is really just an assignment statement. So if I already tell you what is the precondition of an assignment statement, you have to use what we talked about earlier to find out what is the post condition of the assignment statement. So in this case, whether whether line 2 is inside the conditional statement or not really doesn't matter because all it does require is knowing what is pre2 and also the answers to the questions. Does the right-hand side of line 2 refer to the left-hand side? The answer is no. Because the right-hand side specifies x, the left-hand side specifies z, x and z do not relate to each other. As a result, we have to use the forget operation. Or rule in this case, doesn't matter, either way you plot it, it's fine. So in order to apply the forget operation, we have to forget everything in pre2 that mentions anything about the variable to the right or to the left. To the one that we are changing. Which one are we changing? The one to the left. So that would be z in this case. So forget everything we knew about z at this point, but there is something that I can say after line 2. And that has to do with x and z. They have to be the same after line 2 because that's the purpose of an assignment statement. So the next line, we can just apply, we can expand what is pre2. Pre2 is x is greater than y, which means there is nothing to forget, nothing to lose, because x is greater than y does not refer to z at all. So we can keep the entire thing. And then after that, we also know that x equals to z. Line 4 is pretty much the same thing, with a change of the conditions. So I have to ask, does the right-hand side of line 4 refer to the left-hand side? Answer is still no. And this time we're dealing with the precondition and the post-condition of line 4. And as a result, we are now changing y and not x. So it is y that has to be the same as z in this case. The precondition of line 4 is x is less than or equal to y, not x is greater than y. So I'm just making minor changes to adapt one solution to the next. And we have y here, x is less than or equal to y. Are there any questions about line 64 to 68 in the document? Questions? Okay. If there are no questions, then we are at the most important part of a conditional statement, which is at the end. So if you look at the conditional statement itself, which is line 43 to line 47 in the document, after line 2, we go all the way out to the end of the conditional statement. After line 4, we do exactly the same thing. So now the question is, if I'm standing on line 5, okay, or right after the entire conditional statement, what can I say? Well, the problem is you have not insomnia, but you have, what is the symptom of not remembering things? Amnesia. So you cannot remember which way you came from. You know where you are, but you have no idea which way you came from. You know that you have to come from one of these two paths, one and only one of these two, but you don't know which path you took. So if you're standing at the end or at the junction of the two paths, the only thing you can say as a post condition of line 5 is I took one of these paths. And the way to say that in a post condition is I know that I either came from line 2 or I came from line 4. So the post condition of the entire conditional statement is the post condition of line 2 or the post condition of line 4. Note that I did not say either. Okay? If I say either, it means one has to be true, the other one has to be false. But there's no guarantee that one has to be true and then the other one has to be false. They can both be true in general. So that's why you don't want to use exclusive OR here. You just use a simple OR, which means at least one of post 2 and post 4 has to be true, but they can be both true. It's okay to be both true. It's just that one has to be true. At least one has to be true. Does everybody see the difference between an either or and a regular or, and why it is a regular or that applies in this case? With a text editor, this is pretty easy because what I usually do is I just start with parentheses and or, and I just copy and paste. So we have this as our post 2, and then we have this as our post 4, and we're done. I'm not going to do any additional simplifications. Now in this case, they cannot be both true at the same time, because you cannot have x is greater than y and x is less than or equal to y at the same time. So therefore, these two cannot be both true at the same time. But in general, with a conditional statement, you can have cases where the post condition of both branches are true at the same time, or they can be the same thing.
What kind of situation would you need to have both sides of a branch be the same thing?
Well, let's have another example. Okay, the next example looks like this. It says, if x is greater than k, and x is x minus k, and if. Well, to make and if a little bit easier to handle, we'll just end up with a line here that does nothing. Here's line 2, line 1, line 2, 3. Okay. But in this case, I have to give you a more specific precondition. The precondition of line 1 is k is greater than 0, x is greater than 0, greater than or equal to 0, and x is less than 2k. So that's the constraint as a precondition to line 1 in this case. Are we doing okay so far with this? Now we want to do some analysis, just like with the other. I always start with pre2 here. So pre2 in this case cannot just say, oh, you know what, I can conclude that x is greater than k. Well, that's one of the components. But in the case of a pre and post condition, the more specific, the better, because we want to be able to state more instead of less when we get to the pre and post condition of a particular statement. So in addition to knowing that x is greater than k, we have to say that pre1 is true, and on top of that, the condition of the conditional statement is true too. That would be the correct way to do it. Does everybody see the difference between the first approach, which is just saying the condition of the conditional statement has to be true, versus this one, which is saying a lot more? Because it's saying not only is the condition of the conditional statement true, but the precondition of the entire conditional statement also has to be true. Yep.
Without the constraint of pre1, then on pre2, x could be greater than 2k. Whereas
Correct.
With pre1, it constrains it to being less than 2k.
It has to be less than 2k. Then by the time we get to line 5, then we can see how both branches can basically express the same post condition. So they're both true at the same time. So in this case, we just expanded, k is greater than 0. We can never get rid of this one because there's nothing here that can change k. X is greater than or equal to 0, x is less than 2k, and x is greater than k. Okay. Now you can look at this and we can simplify at least one of these terms out. Which one do you think we can toss? Well, let's look at each one by one. Go ahead.
Say you could toss the x is greater than or equal to 0. because
Yep.
you have
X is greater than k, and k is greater than 0. Yep. Okay, but why? Why can we toss such a term out? And what is the rule? What tells me that this term here can be tossed out? Well, if you look at the entire thing, they are all using conjunction to join all the different terms together. In other words, with each additional component, I'm trying to make it more and more and more restrictive, right? In the process of making it more restrictive, if one item is more general than the other ones, then it's not really adding any value because I have other ones to help me narrow down way beyond that point anyway. So the more general term can be tossed out.
Well, also, if x is greater than k, then x has to be greater than 0 because k has to be greater than 0.
Exactly.
So then you can't have x equal to 0 anymore.
Yep. Well, x cannot be 0, but just say that x is greater than or equal to 0, it's still okay. It's not contradicting with anything because x is greater than or equal to 0. It's still including x is greater than 0. So it's not contradicting, but it is not helping either. So if you want to simplify in this case, we can simplify a little bit, and it becomes like that because that term does not do anything. It's not contradicting, but at the same time, it's not helping. So we can just kind of toss it. But this step is optional, okay? Because you don't have to optimize your expressions. Is there anything else we can toss out at this point? Can we toss out k is greater than 0? Is anything else implying that k is greater than 0? No. None of the terms is expressing that. Can we toss out x is less than 2k? No. Knowing that it is greater than k doesn't imply that it is less than 2k, and vice versa. Okay, we cannot toss out x is greater than k either, because none of the other terms indicates that x has to be greater than k. Okay. All right, so now that we know what is pre-2, this is one of those cases where it actually makes sense to try to derive post-2 right away, because we're already on this train of thought, and it really does make sense to kind of go through it here. All right, to derive the post condition of line 2, the fact that it is inside the conditional statement does not matter because it only depends on the nature of line 2 itself in this case because it is an assignment statement. So once we know the precondition and we know the properties of the assignment statement in terms of the right-hand side and the left-hand side, we should be able to derive the post condition of the same line. So now we ask the same question. Does the right-hand side of line 2 refer to the left-hand side? The answer is yes. So it's encouraging. Does the right-hand side of line 2 have an inverse function? Well, let's take a look here. It is x gets x minus k. If f of x is x minus k, is there an inverse to do to undo that operation?
X plus k.
F prime is x plus k. Oh, but Tag, you said something about 0 being special. So would this work when k equals to 0? I mean, obviously k cannot be 0 because as a precondition, k is greater than 0 to begin with. But just in general, if k is 0, would x plus k still be the inverse of x minus k? Yes. Yes. In fact, they are the same function. It's just f of x is x. So plus 0 minus 0 doesn't change it at all. Okay? All right. So now that we know there's an inverse function, then we can say that, okay, now we can say that we can use the substitution rule. Until you find an inverse function, you cannot make that conclusion. You must have an inverse function before you can use the substitution rule. All right, well, knowing that now we can use the substitution rule, it is just a template. Okay, we're applying a template here. X is the variable on the left-hand side, the one being changed. And then we apply the inverse function. We replace it with the inverse function applied to x here. And then we can do the actually expand out the terms. So just copy and paste this one here. And we replace x with x plus k, not x minus k. All right, the first term is k is greater than 0, does not have any references to x. The second term is x is less than 2k. It becomes x plus k is less than 2k. The last term is x is greater than k, so it becomes x plus k is greater than k. All right? Okay, now in the actual exam, this is fine. Okay, this is all that I'm expecting is the mechanical application of the substitution operation. But I personally look at this and I'm bugged that it can be simplified. Okay, so I'm just gonna go this one extra step to do the simplification. K is greater than 0 cannot be simplified anymore, but this one can. One side says x plus k is less than 2k, but one side says x plus k. The other side 2k is really k plus k. If both sides have plus k, we can just simplify the plus k out of both sides. So now we have x on one side and k on the other side. And then the last one looks like it can be simplified as well, because the right-hand side is just simply k, but that's also 0 plus k. So we have plus k on both sides again. So this time we can also simplify it so that it becomes x is greater than 0. Okay. I'm going to leave the code alone here.
Resisting the urge to be a perfectionist.
Right, because the algorithm, the original algorithm is wrong. I actually intended line 1 to be x is greater than or equal to k. But I'm not going to make any changes here because I have to propagate all the changes through the entire thing. So I'm just going to leave it the way it is. All right, so we're done with post 2. On the other side, we have pre-for and post-for. Okay, so let's deal with pre-for first. Pre-for means, what do we know for sure? Every single time we are about to execute line 4, what must be true? Well, pre-1 still must be true because, we haven't got a chance to change anything yet. If we're about to execute line 4, the condition of the conditional statement has to be false. Right, so we have pre-1 and not the condition of the conditional statement, which is x is greater than k. Pre-1 has to be expanded, so it has to be expanded to whatever was given to us. And then the other one can be simplified. It is not the case that x is greater than k, is to say that x is less than or equal to k in this case. All right. Can we simplify anything here? There's something that can be simplified.
Same thing as last time. Same thing as last time.
X is greater than or equal to 0 cannot be simplified out anymore. But there's one other term that can be simplified.
Could you take out the x, or the x is less than or equal to k?
Not that one. That one is more specific than the other one.
K is greater than 0.
Nope.
That's the last one. That's the last one.
No, we simplify out x is less than 2k. Because x is less than or equal to k implies x is less than 2k already, because k is positive. Right? So the simplification goes like this. X is greater than 0 cannot be simplified because it doesn't express its relationship with x whatsoever. x is greater than or equal to 0 forms the lower bound of x, and nothing else here, says anything about the lower bound of x, so that cannot go away either. Now, both of these are basically stating the upper bound of x, right? And they seem to be related. They both mention something about k. So this is the only candidate. These are the only two candidates that we can consider to be simplified. So now we have to find out which one implies which other one, because the one that can be implied can be tossed. X is less than 2k is implied by x is less than or equal to k. So that's why that's the one that has to be that we can toss. So the whole thing simplifies to x is less than or equal to k. Okay, are we doing okay so far? All right. What about the post condition of line 4? Tag, I think you have to take this question out of consideration because we never talked about what to do with nothing. In terms of the pre and the post condition, what is the post condition if a statement is do nothing?
It's the precondition.
It's the same as a precondition, exactly. So this is the kind of thing where I don't really have to talk about it in the class. Just from the statement itself, from the nature of doing nothing, the post condition has to be the same as the precondition. Okay. So the post condition of line 4 is going to be exactly the same thing. Now we look at the post condition of line 5, which is the merge of the two paths. So we already knew before that this is the post condition of line 2, which is one side of the branch, or the post condition of line 4, which is the other side of the branch. So now we have this guy and this guy as the condition. I'm going to wrap it around like this, so it's a little bit easier to look at, like that. Okay. Yep.
For the test subset, did you say post 4 equals pre-4 instead of putting the...
Yeah, then you say they're the same because it's a statement that doesn't do anything. But most of the time, we don't have else do nothing. We just do not have that at all. I put it here just so that it's easier to visualize, so that we can analyze the pre and post conditions a little bit easier. All right. So now the question is, can they both be true at the same time? In other words, can I be on line 5 and look at the values of x and k and say, you know what, this expression is true and this expression is true at the same time? Yeah. They can both be true, okay? So that's why it's not an either or. It is not an exclusive or relationship. They can both be true. The only requirement as a post condition of an entire conditional statement is at least one of the post condition has to be true. Yep.
Just for personal sake, can you reorder those so it's x is greater than 0 and x is greater than 0 and x is greater or equal to 0 above each other? Just
Absolutely.
Okay, because it's just being in statements that they're swappable.
Yep. And the best way to do it is to take the and with it. Then you can just do a Control X and a Control V. All right, space. You did say line up. Now they're lined up.
Just for a visual.
No, absolutely, that makes sense. Okay, now the question is, what if I did not make that little mistake earlier? Now there are still you can definitely tell that both conditions can be true. You can find lots and lots of instances where k is 5 and x is 1, and both of these conditions are true. But what if I did not make that mistake earlier? Instead of x is greater than k, I specify x is greater than or equal to k. Yep.
And the last two statements, so x is less than k, x is less than or equal to k, and the following be x is greater than k.
It's not just that. You're really on the right trail, but it's not exactly that. So instead of changing everything here, which will be exceedingly confusing, I'm going to copy and paste it. So we will basically say, but what if tech did not make that mistake and actually have an equal symbol here and say that x is greater than or equal to k? That's the only change. Okay. So let's see if I can go ahead and quickly propagate the changes, throughout the code here. It doesn't change pre-1, so pre-1 is still pre-1. It does change pre-2 because it's now greater than or equal to k. This is greater than or equal to k. This is greater than or equal to k. Are we still doing okay so far? I'm just looking at all the cases where I state x is greater than k and change those to x is greater than or equal to k. Same thing for post2, because post2 is closely related to pre2. So every time we see greater than k, we replace it with greater than or equal to k. And this time, we have x is greater than or equal to 0. Okay? And okay, that's that. What about pre4? Well, same thing. We have x is greater than k changed to x is greater than or equal to k. And if that is not the case, that means if it is not the case that x is greater than or equal to k, it means x is less than k. Is that okay? In other words, this change to add this equal symbol here means the negation is changed to this. Now the negation is carried on through all of these things here. What do we have as a post2 or post4 now? Okay, let me just change all of this stuff here and do some copy and pasting. They are not just closely related. They're identical. They're identical. Okay. Yep.
If x is less than k is greater than 0, then x can't be 0, right?
X can't be 0 in this case because the lower bound is 0, but the upper bound is k, or k minus 1 because it cannot get to k itself. But k can be 0. I mean, x can be 0.
X can be 0 even though k is greater than 0 and x is less than k.
Right, because k can be
yeah,
1 and x can be less than.
Because k is only the upper bound, it doesn't say anything about the lower bound. Yeah. So that's the original intent of the code, is not to only have both branches to be true at the same time, it's having them to be actually identical. In other words, yep, go ahead.
I was just going to say, well, what kind of application would this be used for if you're doing this if but it gets the exact same answer?
That's a very good question. This code here is actually used a lot, at least in the past, in drawing lines. But let me simply, let me finish this one first, because if I am really picky about, doing simplifications whenever I can, this is the actual end result. Okay, I don't need the extra parentheses anymore, because the two sides of the conjunctions are exactly the same. In other words, we have A or A. A is true if and only if A is true. So the entire disjunction has to be true when A is true. The entire disjunction has to be false when A is false. So it doesn't make any sense, or it doesn't add anything to say A or A. It's just say it's just A. Okay? And this is one simplification that does not apply to arithmetics. You cannot say 1 plus 1 is 1, or A plus A is A, but it makes sense in Boolean algebra when you say A is true or false. Then you can say A or A has to be A, and A is also A. Okay. All right. So let's address your question. Why do we have situations like this? Okay. This applies for drawing lines. Okay. Drawing lines. Oh, I forgot that I had this nifty little thing here, so I'm gonna use the little nifty tool. Let me get some blank paper first.
You need to get a dry erase board. It's under that.
Yeah, I should have done that. Thank you. All right. What we'll do is we'll switch to. Oh, I think I closed that screen already. That's okay. camera is not connected. Alright. Unplug and then plug it back in. Check the system message. Oh no.
Is this plug right here secure?
Yeah, it should be plugged in because the device is actually recognized, but it won't talk to the camera. Ah, okay.
Do you force it?
Huh?
Force it.
I think it's just the driver cannot be unloaded either. Okay. Do one more thing to check. Driver.
More of a non sequitur. What class would you take to learn how to do what you're doing right now?
All of them.
Well, the easiest way to put it is years and years of endless frustration.
Linux class.
Hmm?
Oh, Linux class.
Okay, it's UVC video. Okay, so let me see if I can do this. Oh, forgot I changed my root password too.
What was that LS1 created there?
Hmm?
It lists all the drivers that are loaded.
List modification.
Yeah.
So, what was it? UVC video. It's in use.
You may have to unload it and reload it.
No, this should do it. I mean, it means some process is using it that I cannot see.
Scroll through.
Oh, it's still running. The other one is still running. So it's holding on to it, except the screen is gone. So to kill the process first, 4721. And that should do it.
The never-ending joys of technical failure.
We're gonna make it work.
Is the device still there? Oh, it's recognizing as video 1. So that means if I disconnect, reconnect, it's still listing as video 1. Okay, can I change the device? -D. Yay!
Wow. Masterful.
Yes, I could have just used the whiteboard.
Well, I found that educational.
It's an obsession.
You didn't stop, that's for sure. You were going to stop, but you didn't.
It was a challenge.
Good
I antagonize you.
Exactly.
Sorry.
Oh, there were times I had to spend like hours or even days to get a driver to work, because when Wi-Fi first came out, most of the drivers would not support Linux. So in order to use Linux with a Wi-Fi card, you have to recompile the kernel, you have to add the drivers, you have to download the source code of the kernel, patch it, and then recompile the entire thing, and then figure out that it's still not working, and then you have to re-enable some options, and okay, is that working or not?
It's still about that bad. If you use
It's not quite that bad now.
If you use Intel wireless ones, you do, because you have to get the right driver, because open source doesn't work.
And now I've completely forgot what I was supposed to do on this piece of paper.
Drawing lines.
Oh yeah.
Oh, yeah.
Okay.
Drawing lines when.
Drawing a line.
Besides
Okay,
the
now
computer.
that seems to be pretty easy. Okay, I think I can start with coordinate systems here in this class. Okay, so this is, let's say I'm drawing a line from the origin, which is 0, 0, has a particular slope. Okay, so you have y equals to mx. M is the slope of the entire thing.
It's working faster. It's working faster.
A lot faster.
Yeah.
it is.
Uh-oh, I better double check the recorder is still on there. It's one thing and then another, right? I mean, cascading failure is the worst kind. But the failure is usually cascade. Where's my terminal for the recorder.
Is it recording audio? Okay.
It's still recording, but I cannot find the terminal. Okay, here's one terminal. There's no recorder on it. Here's another one. I must have one that is hidden somewhere. Oh, that's. Well, the recorder is still going. Let me just double check. Look at the file itself. Today, 700. Yep, the file is still going. I mean, you can see that the file size is changing. Yep, it's still recording. It's just that I cannot find the terminal.
Don't ever.
All right, fine. Okay.
It's
All right.
still working.
Okay.
You don't need to watch
So
it work.
anyway,
It's working.
but this is the application of that little snippet of code that I was talking about. How do you draw this line on the screen? That's the question. Okay. Now you know the screen is rasterized, which means they are made out of individual pixels. Okay. Well, you guys all know that stuff already. So how do I know which dots to change color when I'm drawing a straight line? You already know that y equals to mx. So that seems pretty easy, right? I mean, you just move x and then you calculate the y and say, I want to change this dot to a color, move x over by one more, calculate the y, and then change that one dot. Okay? That works out okay with processors these days, or I should say GPUs, because most of this stuff is actually done by the GPU. It's not really done by the main processor anymore. But if you think about this, and say, okay, but what if I'm working with an Apple IIe computer, the original Apple IIe computer from the early 80s, late 70s, early 80s? It doesn't have hardware multiplication. MX is a multiplication. Now, if your processor does not support multiplication in the processor itself, multiplication is a very expensive, long, lengthy operation. So you don't want to do that. Otherwise, you'll be drawing a line like people actually can see the dots, being painted on the screen. Okay, so that's not a good thing. So what people actually do instead is they maintain, a sum. So we'll add one additional term here. We'll call that W. Okay, so we add a W term here. For each dot, every time you change x, W gets incremented by M. Okay. Now, W at some point will exceed, the amount of. I have to remember a certain amount. So W at some point will be exceeding a particular threshold that we'll call T, and that's when you have to bump up the row by 1. In other words, Y, in this case, Y gets Y plus 1, because it will just be the next on the next row. Okay, and this way, they can avoid using multiplication altogether. And everything that we specify here, which is integer addition, integer comparison, and just increment, they are extremely fast compared to multiplication. And that's how, in older computers, even with an 8-bit processor that has no capability of doing hardware multiplication, they can still draw lines relatively fast. It's because of this trick. If you guys want to, I can try to remember, how to set up the threshold, because the threshold is really the key. Is how do I, when do I increment? And every time you increment the line, you also have to do the same thing as we did earlier. You have to subtract W from. You have to subtract the threshold T from W, and so this is the code to draw a line, quickly.
Is the threshold where you're looking at the screen?
No, the threshold has to do with the resolution. It has to do with how frequently you have to. It's the relationship between M, every time you add something to W, and the threshold that determines how rapidly you have to bump it up to the next line. And I cannot remember. Oh, okay, I think I remember now. Okay, so because if you look at a line here, okay, I know you guys want to go. Okay, but if you look at the slope of a line, You can express it as an m, which is a fraction or a a value that is less than 1. But you can also express the slope. M is basically, if I look at this line here and look at this as this is height, and this is w. Okay, this is it. This is width, and this is height. Yeah, the m here is the height, and the threshold here is the width. Okay, so it makes sense. Okay, if you just kind of think about it from the logical perspective, if it is a flat line, which means there's no height, then every time you're just adding 0 to w, and it will never exceed the threshold. On the other hand, if you have a shallow slope, then you have a small value for height and a relatively large value for width. So that means it stays on the same line for a long time, and then they bump up once, and then it stays along in the same line again, and they bump up once. If you have a 1-to-1, which means the slope itself is exactly 1, then every time you add height to it, it's because it's the same value as width, it will exceed the threshold, it will bump up the line, so it becomes a diagonal, where the slope is just 1. And so that's the approach, to draw a line, a straight line, in those days when computation power was expensive. And this is exceedingly fast compared to having to do multiplication. All right, so I'll see you guys on Thursday, and it will be a final test review on that day.
I have something of a non-sequitur question. Do they still use that trick on a computer?
They probably still do it as much as they can, because multiplication, even though it's fast with a Pentium processor, it still uses up an ALU for things that could be used for something else at a time. So with hyper-threading, you want to free up the ALUs unless you absolutely have to use them, because whatever you free up, another thread can come in and say, hey, I can actually use that.
Did they have a name for that? Do we have a name for that?
For
that algorithm that you're using?
Oh, you mean for this?
Technique, that technique.
There has to be a name for that, but I don't know the name for it.
Odds are there's a name for everything.
I use this a lot also, for controlling stepper motors.
Controlling what?
Stepper motors.
Stepper motor, yeah.
Because with stepper motors, the frequency is really kind of tricky, because you cannot change the frequency by a large degree, and then the motor would just stall. But how do you approximate the frequency when frequency is actually time divided by period? So I use this trick a lot to control the speed of a stepper motor, but in a smooth way. Cool.
I have a question that's related to your video program, but
Okay.
wait if there's more important ones.
I was just did they get rid of the assembly class?
Sorry?
Did they get rid of the assembly class?
310?
Yeah.
It's not offered in the fall. It's only offered
Oh,
in
okay.
the spring.
Oh, it's only after in the spring?
Yeah, that one is only offered in the spring when you have some other heavy-duty 400 series classes going on at the same time.
Okay, that...
But I think in some other college, in some other sister colleges, assembly may be offered in
Sac City has it.
Oh, okay.
in the fall.
Yes.
And I think
Because
it's Douglas who teaches it, right?
Yes. At ARC, they alternate so that like 300
Give you a tip.
it will be
I
in
found special
the
dealing with
spring,
cameras.
Mhm.
and 360 in the fall, and then 310 in the spring.
Here,
The
make
next
sure that
spring.
all your
Okay, well I have to
DSPs are
take
gold.
316.
Mhm.
His, but
Better
there was
conducted.
I didn't see it on there.
Quality will be a little bit
He's
better.
taking
Take 360 in the
It's
summer.
not a major change.
You can take 360
but
in
your
the summer.
quality is
No, I have to take pre-cal.
More
in the summer.
consistent.
More consistent, because gold is a better conductor than
Over
silver,
the summer.
and it will give you a better picture resolution.
Oh, okay.
I remember that from my Navy days.
I see. Well, with USB, it may not be helpful as much because it's digital, so
Well,
you're not losing
When
any.
I used to use a lot of USB camming and stuff, especially with USB connections. I found that I use all gold connectors, and my quality improved tremendously.
I know with audio stuff and high frequency stuff, that makes a difference.
Are you talking about like a gold USB 2.0? Like you're still going to top out at like 10 megabits per second, but I mean,
Yeah.
it might make it a little bit faster. I was going to see if you
But
could enable.
it'll improve your picture quality. That's like I use on my RJ45 jacks, on my RJ45. All of them, I make sure all of them have gold connectors on them.
Turn on the FPS thing before you close it.
Go ahead.
The
That's what I
final
thought.
exam that you have posted online on Moodle,
Mhm.
how close is it going to be to what you're going to have this year?
I think it will be, in terms of the types of questions, it will be pretty much, there. But in terms of the exact questions, it'll be a little bit different.
Okay.
Yep. You can even check out the video clips from last year, of the final review, because the final questions were never explained because there were no class after the final exam. But you can also look at the final review of last year. Every year is about the same kind of question. It's just, the actual questions are different.
Perfect, thank you.
Mm-hmm.
I was going to have you turn on your video program. Ah, there it is.
Yeah, there it is. Yeah.